Now we will discuss different types of chemical reaction. Mainly there are 5 types of chemical reaction: combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation reduction reaction. Now before we start discussing about combination reaction, let us discuss about an activity. Quicklime or calcium oxide. The formula of quicklime is calcium oxide, quicklime. It is added to water taken in a beaker. The reaction occurs with a hissing sound and the beaker becomes very hot. Heat energy is produced. A substance is formed. The chemical reaction occurs between calcium oxide and water. Calcium oxide reacts with water with the evolution of heat energy and slaked lime is formed, calcium hydroxide, and heat energy is given out. So you can see calcium oxide is reacting with water and forming calcium hydroxide. Two compounds react and form one single substance. We can discuss some more examples, like when, as we discussed earlier, when magnesium ribbon is burnt in air, it forms magnesium oxide. Here you can see two elements are combining and forming a single compound. When carbon is burnt in oxygen, then carbon dioxide gas is produced. When hydrogen is burnt in air in oxygen, it reacts with oxygen and forms water. You can see what is common in all this. Can you think about it except this? 1, 2, 3, 4. In all these 4 equations, what is common? That in all these reactions, 2 elements or compounds are reacting and forming one single compound, one single substance. So these are all the examples of combination reaction, in which 2 elements or compounds are reacting to form one single substance. So we can define now combination reactions. Combination reactions are those reactions in which 2 or more substances combine to form a single substance. Combination reactions are generally those reactions in which heat energy is evolved, generated, and such reactions in which heat energy is evolved are called exothermic reactions. Exothermic reaction, now we can define them, is a chemical reaction which proceeds with the evolution of heat energy. So heat energy is evolved, it is a exothermic reaction. There are some more examples of exothermic reaction. When methane gas is burnt in oxygen, a lot amount of heat is generated. It is an exothermic reaction. Formula of methane is CH4, it is a gas. When it burns in air, it combines with oxygen and it forms carbon dioxide and water, and a lot amount of heat energy is generated. Respiration takes place inside our body. It is another example of exothermic reaction in which energy is produced. Glucose present inside the body reacts with oxygen and forms carbon dioxide and water, and energy is generated. So these are some more examples of exothermic reactions. Now we will discuss second type of reaction, that is decomposition reaction. Now in this case, first of all we will perform an activity. We will discuss an activity. Take ferrous sulfate crystals in a dry glass test tube. Now, ferrous sulphate is green in color. Heat it over the Bunsen burner's flame, holding it with the help of an holder. Now, what happens? When it is heated, some gases come out which have pungent smelling gases come out. Now, these gases are sulfur dioxide and sulfur trioxide. On heating, what happens? The color of ferrous sulphate, which was green in color, changes to brownish black. What happens actually? The reaction occurs, ferrous sulphate decomposes into 3 compounds: ferric oxide Fe2O3, sulfur dioxide and sulfur trioxide. Another activity which can be performed in the lab in the same manner, in a dry glass test tube, lead nitrate crystals PbNO3 whole twice are taken and heated over the flame of Bunsen burner. Now, what happens? A gas is evolved which is reddish brown in color. Now, this gas is nitrogen dioxide. In this case also, lead nitrate PbNO3 whole twice forms lead oxide, nitrogen dioxide and oxygen. One compound forms 3 compounds, 2 compounds and 1 element, oxygen. Another solid substance, calcium carbonate, when it is heated, it is white in color. It again forms calcium oxide and carbon dioxide, which is also white in color. There is no change in the color. Now, what is common in all these reactions? Can you see that one compound is breaking down into 2 or more compounds or elements in all the cases, in the second case also, in the third case also. These type of reactions in which a compound breaks in 2 or more substances is called decomposition reaction. This type of reaction is known as decomposition reaction. So, now we can define decomposition reaction is the reaction in which a chemical compound decomposes to form 2 or more substances. Now, you have seen that in all these decomposition reactions, energy is absorbed in all these 3 cases in the form of heat. On heating, all these 3 reactions occurred. Energy is absorbed in all these reactions, and all these reactions are also called endothermic reactions because energy is absorbed in the form of heat. Endothermic reactions. These are all endothermic reactions in which absorption of heat energy takes place. These are called endothermic reactions. Endothermic reactions are those which proceed with absorption of heat energy. Now, here one activity can be performed by taking the salts barium hydroxide and ammonium chloride. On the palm, put some water over it and make a paste. Palm feels colder because the absorption of energy has occurred. So, this is the example of an endothermic reaction. One more example of decomposition reaction can be done in the form of electrolysis of water. Here energy is supplied as in the form of electric current. Here also energy has to be absorbed, then only the reaction occurs. Water here will break into hydrogen and oxygen when electric current is passed through water. This is also another example of decomposition reaction. Now, this reaction is also called electrolysis of water. Electrolysis is that reaction in which a compound decomposes into 2 or more substances by passing electric current. Now, for this a plastic mug is taken, plastic mug, At the bottom it is fitted with 2 rubber stoppers and carbon or graphite rods are fitted in these stoppers which form the electrodes. Now, these carbon or graphite electrodes are connected to a 6-volt battery. The electrode which is connected to negative terminal of the battery is called cathode, and the electrode which is connected to the positive terminal of the battery is called anode. To make water a good conductor of electric current, some amount of few drops of dilute sulfuric acid is added. Now, when the current is allowed to pass through water, water decomposes into hydrogen and oxygen. Hydrogen is liberated at cathode. What happens? Through the test tube it goes up, water is displaced in the downward direction and hydrogen gas is collected at the top of the test tube, whereas oxygen gets collected at anode. Now, you can see one more thing, that the volume of oxygen gas is more or less half of the volume of the hydrogen, because according to the formula the ratio of hydrogen and oxygen is 1:2. Oxygen is 1, hydrogen is 2. We can say it like this. If it is like this, 1:2. So, the volume of hydrogen collected will be double the volume of the oxygen. So, this is how electrolysis of water can be done, and also this is also a form of decomposition reaction, and it is also called electrolysis, in which any compound decomposes into 2 or more compounds or elements by the passage of due to the passage of electric current. There is one more type of decomposition reaction. Silver chloride is a salt. Silver chloride, AgCl, is a salt which is white in color. It is taken in a dish, china dish, and kept exposed in sunlight. It is white in color, exposed in sunlight. After some times, it is found that this salt has changed the color. It has become turned into grey color. A reaction is occurred. Energy is absorbed in the form of sunlight. Now, this reaction which occurs due to the absorption of energy in the form of sunlight is called photochemical reactions. Here the energy is absorbed from sunlight. So, those reactions which proceed in the presence of sunlight are called photochemical reactions. So, when silver chloride is exposed to sunlight, it forms silver and chlorine gas. This is also decomposition reaction. In this case, energy is absorbed from sunlight. Another is silver bromide. Silver bromide also in the same manner, if it is exposed to sunlight, it will decompose into silver and bromine gas in the presence of sunlight. So, this reaction, because it proceeds in the presence of sunlight, it is called a photochemical reaction. Now, we will discuss third type of chemical reaction, that is displacement reaction. Now, before we know what is displacement reaction, let us discuss about an activity which can be performed in the lab. Take 2 test tubes and take copper sulphate and dissolve it in distilled water. Now, on dissolving, you will find that copper sulphate dissolves in water to form a blue colored copper sulphate solution. The color of the solution is blue in both the test tubes. Take equal volume of copper sulphate solution in both the test tubes, and also take fresh iron nails from the market. Now, the iron nails will be shiny, both of the iron nails are shiny. So, these iron nails, one of the iron nail is kept outside and the other iron nail is kept inside the copper sulphate solution. So, before the experiment starts, both have the same color. After few hours, what do you observe? You will find that the test tube in which iron nail has been kept, the color of the iron nail has changed. It has turned brown in color, brown. Brown colored substance has been deposited on it, brown colored substance has been deposited on the iron nail, and also there is a change in the color. The color of the solution becomes light green. Now, see this test tube. In this, because we have not kept the iron nail in this, the color remains the same, it is blue only. And also this iron nail which is kept outside, iron nail kept outside, there is no change in color, or there is no change in the shine of the iron nail, it keeps shining. So, there is a difference not only on the iron nails, also on the copper sulphate solution. Now, what has happened? A chemical reaction has occurred. Copper sulphate solution has reacted with the iron nail. Now, if we write the chemical equation, we will find that we have taken the iron nail, the formula of iron is Fe, and the copper sulphate solution, the formula of copper sulphate is, I think you know, it is copper sulphate is CuSO4. Iron has replaced copper and it has formed ferrous sulphate and copper. Copper sulphate solution is the solution which is made in water. So, it is aqueous solution and iron is a solid. The color is blue. FeSO4 also is a solution in water, aqueous, and its color is light green. Copper is brown in color and it has deposited on the surface of the iron nail. So, we can clearly see here that iron has displaced copper and taken its place and formed iron sulphate. Also, one more thing we will notice from here, what is that? That iron is more reactive than copper. So, two things you can see, one is a metal which is more reactive will displace the less reactive metal from its salt solution. So, such a reaction is called displacement reaction. Now, how to find out which metal is more reactive than the other, you should know the reactivity series. Reactivity series is the arrangement of metals in decreasing order of their reactivity. Potassium is more reactive than sodium, is more reactive than calcium, then magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver and gold. These are the symbols written. Potassium is the most reactive metal and gold is the least reactive metal. So, if we know the order of the metals in decreasing order of their reactivity, we can predict whether the reaction will occur or not. So, now we can define displacement reaction. Displacement reaction is a chemical reaction in which a more reactive element displaces a less reactive element from its salt solution. Okay. Now, these are some of the reactants written here. By seeing this, we can predict whether the following reaction will occur or not. Zinc and copper sulphate will react or not. Now, from this reactivity series you can see zinc is more reactive than copper, so the reaction will occur. And what will be the products formed? You can very well think, because the displacement reaction will occur, it will form ZnSO4 plus copper. Now, here also lead Pb plus CuCl2. So, let us see from this reactivity series. Lead is more reactive than copper. So, the displacement reaction will occur, and what will be formed? Let us see. Displacement reaction will occur. So, Pb will displace copper and form PbCl2 and copper. Now, see the third reaction, Cu plus FeSO4. See the reactivity series again, but here you will find what Fe is here and Cu is here in the reactivity series. Fe is more reactive than Cu, iron is more reactive than copper. Will this reaction occur? The answer is no. The chemical reaction will not occur, because a less reactive element will not displace a more reactive element from its salt solution. So, here no reaction occurs. Now, we will discuss fourth type of chemical reaction, that is double displacement reaction. Now, for this reaction also, how to understand this reaction, let us discuss an activity. Take two test tubes and take two salts. One is barium chloride dissolved in water, it forms a clear solution, barium chloride solution in water. And sodium sulphate solution, salt is also dissolved in water to form sodium sulphate solution. Thus, two solutions are mixed. It is found that on mixing the two solution, the insoluble substance is formed, insoluble substance is formed. A chemical reaction has occurred. This insoluble substance formed is called precipitate. In short, we can write it as PPT. Some chemical reaction has occurred. Sodium sulphate aqueous solution in water has reacted with barium chloride solution in water. Now, what has happened? Sodium has displaced barium. So, what will it form? It has formed NaCl, and barium has displaced sodium and taken its place and has formed barium sulphate, which is a precipitate. So, barium sulphate has precipitated. The precipitate can be indicated by an arrow in downward direction. So, this reaction has occurred. Here exchange of ions has occurred. So, such type of reactions are called double displacement reaction, because the displacement has occurred two times. So, we can now define double displacement reaction. It is a reaction between the aqueous solutions of two ionic compounds. Both are ionic compounds. Reaction between the aqueous solutions of two ionic compounds which react by exchanging their ions. Ion exchange has occurred to form two new compounds. So, such type of reactions are called double displacement reaction. Let us see one more example of double displacement reaction, silver nitrate and NaCl. When silver nitrate solution is taken, aqueous solution, and added to aqueous solution of sodium chloride. Now, before we write the products, one thing you keep in mind that both are ionic compounds. What will be formed? Because exchange of ions has occurred, it will form AgCl and NaNO3. Exchange of ions has occurred, double displacement reaction has occurred. AgCl is an insoluble salt, that is precipitate, which can be shown by downward arrow, and sodium nitrate is an aqueous solution. Now we will discuss precipitation reactions. Just now I discussed with you double displacement reaction. Precipitation reaction is also a double displacement reaction. Now what is it which makes it a precipitation reaction? Let us see. Earlier, right now we had discussed the reaction between Na2SO4 and BaCl2 solutions. Both are ionic compounds, and we have seen that insoluble substance has been formed, which is called precipitate. So these reactions in which an insoluble salt is formed, precipitate is formed, are also called precipitation reactions. So this is an example of not only double displacement reaction, it is also precipitation reaction in which a precipitate has been formed. Here a white precipitate has been formed of barium sulfate, which will settle down if we keep the test tube for some time. So now we can define precipitation reaction is a chemical reaction in which aqueous solutions of two ionic compounds react by exchanging their ions to form two new compounds, in which one of the compound formed is an insoluble salt, which is called precipitate. So a precipitate is formed, that is why it is also called precipitation reaction. Some more example, this we have already discussed, it is an example of double displacement reaction also and precipitation reaction also. Here a white precipitate of AgCl has been formed. One more example of precipitation reaction as well as double displacement reaction is the reaction between lead nitrate solution and potassium iodide solutions in water. Let us see what happens. Here a yellow precipitate of lead iodide is formed. So this is a yellow precipitate which has been formed. So in precipitation reactions as well as double displacement reactions, condition is same. The compounds which react should be ionic, should be dissolved in water, aqueous solutions should be taken, then only the exchange of ions will occur and double displacement reaction will occur and also a precipitate will form. If a precipitate also forms, then it is called precipitation reaction. Now we will discuss about another type of reaction, that is oxidation and reduction reactions. So first of all we will start with oxidation reactions, and before explaining what are oxidation reactions, let us discuss an activity to be performed in the lab. For this activity, take a china dish and take brown colored copper powder in the china dish as shown in the diagram and fit the apparatus. Let us see what type of apparatus is being used. China dish is taken and copper powder, which is brown in color, is taken in the china dish, placed over the tripod stand fitted with wire gauge. Wire gauge is placed over the tripod stand and copper powder is heated with the flame of the Bunsen burner. It is observed that after some times brown colored copper powder changes to black colored substance. A chemical reaction has occurred. Copper has reacted with oxygen present in air and formed black colored copper oxide, as you can see in this diagram. Now we can write the chemical equation. 2Cu plus O2 gives 2CuO. Cupric oxide or copper oxide is black in color, whereas copper powder is brown in color. Now you can very well see that in this reaction oxygen has been added to copper, and such type of reaction is called oxidation reaction, where addition of oxygen from a to a substance occurs. We can now define what is oxidation. Oxidation is a chemical reaction in which addition of oxygen or removal of hydrogen from a substance occurs. So you can see this is the definition. Some more oxidation reactions we can discuss right now, like burning of carbon in air, burning of magnesium in air, and the respiration process which takes place inside the body, where glucose is burnt in the presence of oxygen to give energy and to form carbon dioxide and water. Let us see what happens when carbon is burnt in air. It combines with oxygen present in air and forms carbon dioxide gas. And also when magnesium is burnt in air, it also combines with oxygen present in air and forms magnesium oxide. And similar way, glucose which is present inside the body is decomposed, is burnt in the presence of oxygen present in air to form carbon dioxide, water and energy which is used for doing the various activities by the body. Now what happens when another activity is performed in the lab? Hydrogen gas is passed over heated black colored copper oxide. After some times it is observed that what happens? This black colored copper oxide turns to brown colored copper. A reaction has occurred. So let us discuss this activity with the help of the diagram. Here this is a glass tube in which black colored copper oxide has been taken and it is heated, and hydrogen gas is passed over it. After some times this black colored copper oxide changes to brown colored copper on heating. A chemical reaction has occurred. Now what is the chemical reaction which has occurred? Let us see from this equation. Copper oxide on heating reacts with hydrogen gas and forms brown colored copper and water. Now you can see copper oxide has changed to copper. Oxygen has been removed, and this reaction in which oxygen has been removed from the substance is called reduction. So now we can define reduction. Reduction is a process, is a chemical reaction in which addition of hydrogen or removal of oxygen from a substance occurs. So this is a reduction reaction. Now here in this particular reaction you can see copper oxide has changed to copper. In this particular case removal of oxygen has occurred and this is reduction has taken place. Copper oxide is being reduced to copper. Now see this, the case of hydrogen. Hydrogen forms water. What happens in this case? Have you observed? To hydrogen oxygen has been added. So addition of oxygen has occurred, and right now you have studied what is oxidation. It is addition of oxygen. So hydrogen has been oxidized to water. Oxidation has occurred. So now what you see in this particular reaction, that both oxidation and reduction are taking place simultaneously in the same reaction. Now we will discuss another type of reaction, that is redox reaction. In the previous type of reaction we discussed a reaction in which both oxidation and reduction were taking place simultaneously in the same reaction. Let us discuss this reaction again here. See this, when hydrogen gas is passed over heated cupric oxide, it changes to copper and water is also formed. Now, in this particular reaction you can see from copper oxide removal of oxygen has occurred, and removal of oxygen is called reduction. So, this is the process of reduction. Copper oxide is getting reduced to copper. In the case of hydrogen, you can very well see that oxygen has been added, and what is addition of oxygen? It is oxidation. Addition of oxygen is oxidation. So, hydrogen is getting oxidized to water. So, you can very well see yourself that in this particular reaction both oxidation and reduction are taking place simultaneously in the same reaction, and such type of reactions are called redox reactions. So, a redox reaction is a chemical reaction in which both oxidation and reduction take place simultaneously. So, this is the definition. Redox reaction, chemical reaction in which both oxidation and reduction take place simultaneously. Now, let us discuss some more examples of redox reactions, like zinc oxide reacts with copper and forms zinc and carbon monoxide. See particular case of zinc oxide, it gets converted into zinc. What do you see here? Removal of oxygen is taking place. Removal of oxygen is called reduction. So, zinc oxide is getting reduced to zinc. Now, see the case of carbon. Carbon is forming carbon monoxide. Addition of oxygen is taking place, and what is addition of oxygen? It is called oxidation. Addition of oxygen is called oxidation. So, in this reaction also, as both reduction and oxidation are taking place in the same reaction, it is an example of redox reaction. This is another example of redox reaction. Now, in this case hydrogen sulfide is reacting with iodine and it is forming hydrogen iodide and sulfur. Now, you can see that H2S is forming sulfur. So, what is taking place here? From H2S hydrogen has been removed, and what is removal of hydrogen? It is called oxidation. So, hydrogen sulfide is getting oxidized to sulfur. Now, take the case of iodine. What is happening to iodine? Iodine is being converted to hydrogen iodide. You can very well see yourself that hydrogen has been added up, and addition of hydrogen is called reduction. So, in this particular case also both oxidation and reduction are taking place simultaneously, and so this is a redox reaction. One more example let us take. MnO2 plus 4HCl forms MnCl2 plus 2H2O plus Cl2. MnO2 is forming MnCl2. What is happening here? You can see yourself, here oxygen is being removed, and what is the removal of oxygen? It is called reduction. So, reduction is taking place, and what is happening to HCl? HCl is forming Cl2. So, what is happening here? Hydrogen has been removed, and what is the removal of hydrogen called? It is called oxidation. So, here also both oxidation and reduction are taking place simultaneously, and so this is also an example of redox reaction.